Hello and welcome to the next lecture. In this lecture, we will look into the optimization example of scoping rules in R programming. So far, we have talked about functions and the scoping rules in R, and you might be wondering why any of this information is at all useful. So in addition to just writing regular functions for manipulating data or for doing calculations, there's one combination of the scoping rules and functions which can be very useful in statistics, and that's for optimization. So there are a few optimization routines in R called optim and NLM, and another one called optimize. And they all require that you pass a function to those functions whose argument is vector parameters. So for example, there's going to be some function that you want to minimize or maximize, and that to our range of parameters, and functions like optim and NLM take that kind of objective function and try to find the minimum or the maximum. So the idea is that, but in statistics, this objective function that we are trying to minimize or maximize, just like a log likelihood, is going to depend on other things besides just the parameters that you are maximizing over. So in particular, it's going to depend on things like data. And the question is, well, how do you specify a function that depends on parameters and data and perhaps many other things in a clean way, and to write it in a kind of readable programming style and make it easier for the user to kind of use these type of functions. And furthermore, when you are doing these kinds of optimizations, in many cases, it's useful to hold certain parameters fixed, and for example, fix a parameter to a certain value, then optimize over the other parameters. So the basic idea with any optimization problem in R is you can create a constructor function which constructs the objective function, and then once the objective function would have all of the data, and all of the other things that it depends on would be kind of included in the defining environment of that function, so that it would kind of carry along those other things like baggage in its enclosing environment. And so that way you don't have to specify those things every time you call the function. The only thing that you need to specify is the value of the parameter. So here I've got a constructor function that creates an active log likelihood. So just as a note, most of the functions like optim and NLM and optimize in R, they all attempt to minimize functions by default. And so when you write your objective functions, if they are designed to be maximized, then you have to kind of take the negative of those functions so that you can minimize them. So another thing is that all the code in this example will be on the blog post, so you can take a look at the code and try to run it yourself if you want. So here I've got a constructor function that's making a negative log likelihood because I want to minimize the negative log likelihood function. So this is my objective function. It's going to depend on some data, and so that's the argument. So the data is the first argument to this make.function. The second argument is a logical vector called fixed, and it determines whether or not I want to fix some of the parameters. So now inside the constructor function, I have to find another function which takes an argument called p for the parameters, and this is going to be the parameter vector that I want to optimize over. So basically what this function is going to do is going to return log likelihood for a normal distribution, and I'm going to want to fit my data to this normal distribution. And so we know that a normal distribution has two parameters, the mean mu and a standard deviation sigma. So those are going to be the two parameters that I want to optimize over. And so here I am just defining the log of likelihood and taking the negative of it so I can minimize it. And what the constructor function does is returns the function as the return value. So here I am going to simulate some normal random variables with mean 2, and then I am going to make my constructor function. I am going to call my constructor function with these random variables and create my NLL or negative log likelihood function. So when I print out this function here, you will see that the body of the function looks like the code for the normal distribution. It's just like in the construction function before, but if you look at the environment, you will see this little tag at the bottom that says environment, and that's the enclosing environment for this function. And so normally, because when you define a function in the global environment, that there wouldn't be a special environment tag down here. However, when you define a function inside of another function, there has to be a pointer to that defining environment, so that R can remember kind of what the values of all the free parameters are going to be, And so if you look at this is 0x165b1a4, that is the hexadecimal of a number which gives the address of where the defining environment is located in memory. So if you look at the body of the NLL function here, you will see that pretty much everything here is either a local variable or it comes with a parameter vector p. However, there's one variable here, the data variable, which is not an argument to the function and it's not a local variable. So it's a free variable, but the data comes from the make.naglog like function or constructor function which originally passed the data to that. And so the data can be looked up in the environment that the function is defined in, and it knows what the data are. You don't have to tell what the data are, it's already fixed in the function. So if you look at the environment for this negative log likelihood function, by calling ls, you will see the data variable there, the fixed variable there which indicates which parameters should be fixed, and then there's also the params variable there. So those are all free variables inside this negative log likelihood function, but they are defined in the defining environment. So now I can call optim on my NLL function and I am going to pass some initial values for mu to 0 and sigma to 1, and it will run, and you will see that when it optimizes the function, the estimates turn out to be 1.2 for mu and 1.78 for sigma. So pretty close to the truth. Remember which was 1 and 2. Now I could, if I wanted to, I could fix sigma to be equal to its true value and then just optimize over mu to get the mean. So I need to reconstruct my optim, my objective function, by calling make.naglog like, and here I set the fixed variable to be false from mu and then 2 for sigma. So I am setting sigma to be equal to 2 and I am letting mu be there. So here now I can just call optimize, because optimize will minimize the function of a single variable only, and because I only have a single variable in this function, I can use optimize, and you can see that it estimates made to be about 1.21, which is slightly different from the previous optimization. I can also fix mu to be 1 and try to optimize over sigma. But in order to do that, I have to construct another function for optimization, and that can call optimize on that. Here I get my sigma to be about 1.8. Now if I want, I can plot the likelihood or the log likelihood, and this is very easy to do when I have a function that does not depend on a lot of other parameters. So here I am going to make the negative log likelihood. I am going to fix mu to be equal to 1 and I am going to plot the negative log likelihood as a function of sigma. And so I construct my function here NLL, and I construct a sequence of grid values for the x coordinate, and then I apply my NLL function to all those grid points and create my y variable. So now I can just call plot the x and the y's and connect the dots using the type equal to L. Similarly, I can plot the negative likelihood as a function of the mean by fixing sigma to equal to 2 and letting mu vary. And similarly, I create another grid of points, another set of grid points, and I evaluate at the NLL function on those grid points and then make a plot. So this is the plot for the negative log likelihood as a function of sigma with fixed mu equal to 1. And this is the plot for the negative log likelihood as a function of mu with fixed sigma equal to 2. So the nice thing about lexical scoping in R is that if you are doing minimization or optimization of some sort, you can build these objective functions which contain all the necessary data and all the other kind of bells and whistles that are required to evaluate that function into the closing environment of the function. So that when you call the objective function, you don't need to specify the data and all those other things every single time. They are kind of built into the environment and they will be automatically looked up in the right place. So you don't have to carry on these long argument lists that in order to evaluate the function every single time. So this can be very useful for interactive work and for exploratory work, like for example making these plots. And so the code for these type of functions can be very simple and kind of clean because you don't have to carry on these large argument lists. So just for reference, the main reference for this type of lexical scoping rules of R is the paper in the General Computation and Graphical Statistics called Lexical Scope and Statistical Computing by Robert Gentleman and Ross Yakha, who created R, have some very nice examples in this article. So with this we have concluded the development part of the R programming. Next up we will look into some inbuilt but very useful functions in R programming that will make your life easy as a programmer, or we should say as a data scientist or analyst. So see you in the next lecture. Till then, ciao.